objective. After reviewing this video, you will be able to describe how the atoms bond, describe how ionic bonding occurs, explain what electrolytes are, identify the different characteristics of ionic bonds, and identify the different polyatomic ions. Bonding. Why do atoms form bonds? Well, atoms become more stable when they acquire the electron configuration of a noble gas. Because all atoms want to have that full outer shell. They want to have a full outer shell. So because they want to follow the octet rule. And do you remember what the octet rule was? Yes. Every atom wants to have 8 valence electrons, except the very first ring. The first principal energy level only wants to have 2, because helium only has 2 electrons, so it can only have 2 valence electrons. Ionic bonds. It's the transfer of electrons from one atom to another, and it occurs between a metal and a non-metal. There has to be an electronegativity difference of more than 2 between the ions for the ionic bonds to occur. And right here, showing 1 valence electron from, this would of course be lithium, transferring over to fluorine, because fluorine wants 1 more electron. We'll talk more about ionic bonds in a little bit, but polyatomic ions, and this is certain elements like to be found together. They behave like one element, so it's like, you hanging out with your friends, and there's certain ones that you hang out with more than others. Same thing with polyatomic ions. There's just a bunch of different elements that like to hang together. Okay, they're the more common. Here are some more commonly used polyatomic ions. I have them listed below. Just copy them down in class. We'll be using them, and I'll explain more about them. Okay, but you have your nitrate, sulfate, hydroxide, carbonate, and phosphate. Electrolytes. Now, I know you guys heard of this word before, electrolytes. They conduct electricity. Electrolytes, electricity. Oh. Now, they require charged particles, and we'll go a little bit more in depth on them in class, but they include your acids, your bases, your metals, your ionic substances. What happens is ionic compounds will, in this case, break down into ions, and the ions allow the electricity to flow through, and so that's why you will see right here a light bulb lighting up, because the salt will break up into an Na plus and Cl minus, and that allows electricity to flow. Did you know ionic compounds dissolve in water to form ions? There are positive ions and negative ions. These ions allow the flow of electricity. We will call these electrolytes. Now, you may have heard, never use a hairdryer by the bathtub. Well, there's a couple different reasons. Well, one of the reasons I'm going to go over is because you can get electrocuted. The dirt and grime from the skin, after you shower, will mix with the water to form the ions in the water. Well, ions allow electricity to form, so the hairdryer hits the water, allows the electricity to flow through, and then rest in peace. bonding. Let's just go over bonding in general. So chemical bonding is the force of attraction that holds atoms together. The purpose of bonds is to increase stability. So atoms will gain or lose or even share electrons. But in ionic bonding we'll talk about gaining and losing. But they'll try to gain, lose, or share electrons to look like noble gases because they want to have that full outer shell and to satisfy the octet rule. So remember, metals form positive ions by losing electrons. Again, metals form positive ions by losing electrons. And nonmetals form negative ions by gaining electrons. Again, nonmetals form negative ions by gaining electrons. Characteristics of ionic compounds. So, they have high melting / boiling points. They're very hard. They conduct electricity when in solution. So when they mix in your water, they form ions. And they form crystalline structures. So ionic lattice is the plus and minus ions are held together in regular repeating structure. So right over here is just trying to show a structure of an ionic compound. Examples of ionic structures. So again, ionic lattices are just the positive and negative ions held together in a regular repeating structure. So let's use the example of potassium and bromine. So to our right, we have, as our little purple spheres, bromine, linked together with potassium, which is in our red spheres. Okay, and this is a pattern of which they would be forming. To the bottom, we will have lithium and oxygen. We will go more in depth naming and structures in a bit in future podcasts. But right now, we have lithium and oxygen. And so we have lithium, which is the red sphere, and is the light purple sphere, we have oxygen. And if you count it up, we would have for every 2 lithium, we have 1 oxygen. So for lithium, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And for the oxygen, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 oxygen and 14 lithium. So we would end up with a chemical formula of L2O. Again, that's just future stuff. Next, we will be moving on to ionic bonding. So let's use the example of sodium chloride. So we have sodium, which has how many valence electrons? 1. And we have chlorine, which has how many valence electrons? 1, 2, 3, 4, 5, 6, 7. Good. Now, in ionic bonding, this is the transfer or stealing of an electron. So, chlorine, which has 7 valence electrons, wants how many more? 1. Okay, and sodium has that 1 little electron off. Okay, so what will happen is the chlorine will come and steal the sodium electron. Think about it as like the chlorine is going to protect the sodium. So the chlorine will go to the sodium and like, hey, I'll protect you, but I'll have to get it charged because it's going to steal electron, changing the charge. Okay, now sodium will now be a positively charged because it lost an electron, and chlorine will be negatively charged because it gained an electron. So sodium's lone valence electron is transferred to chlorine so that both sodium and chlorine will satisfy the octet rule.